Cool. All right. Well, sorry for the technical difficulties. So anyways, so today what I wanted to go over is 3 strategy patterns, but I think we're only going to be able to go through one. Design patterns, but we'll only be able to go through one. So let me quickly go to my GitHub. That way you guys can whack-a-mole. Okay. So what I'm going to do is I'm going to transfer the ownership. Do you guys know that we have the GitHub, right, for SoDA? You guys know that? No? OK, so there's a GitHub for SoDA. So you can find everything under github.com/Software Developers Association. There's a link in the Discord. It should be under announcements. You can go ahead and just click on that. It's going to go ahead and move this over to that. Yeah, I kept doing that. Oops. OK, so you guys should be able to see it now. So it's here. It's a blank project. So you should be able to clone it. Because we're starting super late, hopefully I can go over certain things I wanted to talk about. And there's 3 design patterns I wanted to talk about. And one of them I think is very important. It's the Singleton Pattern, strategy pattern, and the object pooling. So for those that have Unity, when you open up the project, it should just be blank. And I might have added, some scripts here under utility. And I kind of just want to go over, at least for today, hopefully get through the whole thing, Singleton design pattern. And so when you're designing your applications, it's a very good idea, no matter if it's a utility app or a game, that you always use software design patterns whenever you can. It should be like, basically it's a requirement as a software engineer, right? Doesn't matter if you're making a game. And one of the patterns that's incredibly important, I think, is the Singleton pattern. In fact, there's a book by the Gang of 4 called, I think it's Design Patterns, Object-Oriented and Design Patterns, something like that. And they talk about this pattern. Among other patterns that they have collected and studied. And this one is a very important one. It's what's known as a creational pattern. And the main idea behind a singleton is that you control, right, the instance of a specific class. Basically, you want a reference to this object to only exist once in your entire life cycle of your application. And so you might be asking yourself, what are the use cases for such a pattern? And the uses is to introduce a global state by globalizing functionality without polluting the global namespace with static fields and functions. So if you think about it in our context of making it like a game, if you have the player and he shoots like a zombie, for example, you want to increase the amount of points they have, right? And then you have your UI, which obviously is not a part of the rest of the game. It's just displaying stuff. It has no other logic. One thing that, in order to display the score, you need to have access to that score, right? And so a naive way would be to let's just globalize the score so the UI can just go ahead and display the score onto the screen. Now, the problem with that approach of just globalizing it is that if you have different game modes, right, a score in a game that has to deal with maybe distance may be different than a game that has, maybe a score of just regular points and not distance. So one could be float, one could be integer. The other thing is maintainability. As your project becomes bigger and bigger and more complex, polluting the global namespace makes it incredibly harder to maintain. You can cause bugs. It's harder for you to distinguish between objects that should be global and objects that shouldn't. So some of the pros is that you get a global state by using a singleton pattern. You're basically forcing that the entire application, if it wants to use specific logic on a particular object, that no matter what the application current state is, whether in your main menu, inside of the game, that particular object is always there for you to reference. So for example, in a game, you might have something known as a game manager, right? And then your game manager can be a singleton, right? And the game manager can have some basic logic. For example, maybe it has the event for when the player dies, or when you want to restart a level, or when the game is just over. So you have stuff like that. The bad thing about it is that it's hard to debug. To write unit test cases, it's incredibly difficult because the order of events of execution that play on top of the singleton actually matters, because you have this global state, right? So if you have a singleton and in one test case, it manipulates it in such a way where the score is 20, and that's cool. But then in another instance, the score changes to 10. And sometimes you're trying to figure out, why do I have a score of 25 or something like that? And you're not supposed to have increments of 5, only increments of 10. It can be kind of hard to write test cases for it because based off the order of execution will change the state of the object. And so that can be kind of difficult to track down. The other thing is you cannot run test cases or you cannot run code on a singleton concurrently. Meaning if you wanted to do multi-threading with a singleton, you can't, because manipulating the state of the object in parallel can cause undefined behavior. We have no idea what will happen. You can prevent this by locking it using mutexes and stuff, but again, you're no longer doing your processes concurrently. You now have to wait until a specific thread is able to release the object for you to be able to use. So then you lose concurrency. So you can't do parallel programming. You're forced to wait for the other thread to release that object. So it defeats the purpose. So in our case, I wanted to make whack-a-mole. So what we can do is we can actually start by creating a simple game manager script. Just like that. And I want this game manager to persist throughout this game. So no matter if we restart it or reload it, that the game manager sticks around. Okay. Now, the cool thing about the way I built the singleton is that it's just a regular class. But it's an abstract class. And in order for me to force this game manager to become a singleton, I just have to inherit, right? And if you guys know what generics are, generics is basically a way to for you to create variables that you have no idea what the type is going to be just yet, right? So for the singleton, the way it works is you need to have an instance of that particular object, right? But if you don't know what that object is yet, right? In this case, we want to create a game manager class, and we could build a singleton in here, but a nice way is that we can just use inheritance and just inherit from the singleton object, and now we've become a singleton. So the nice thing about C#, which you can't do in Java, is you can actually use static generics. You can't do that in Java. So that's why C# is better. Here's one example of that. So here is our actual instance. And then we're only ever going to have one instance of this particular game manager. Okay. We then have a mutex. This mutex is basically going to work as, if you're taking 139 here, what a mutex actually is. So particularly with different processes or threads, we can call them, sometimes you have shared memory that you don't want to have multiple processes manipulate at the exact same time, because then that can lead to undesirable or unpredictable behavior. So what we can do is we can actually lock, basically creating thread safety. So we can lock our mutex object. So this forces that particular piece of memory is not manipulated by any other thread except the one that currently has the lock. Okay? And now we're just going to do a quick check to see if the current instance is null. And if it's null, this right here is a Unity-based API call. It's basically saying, find the object of type, and then we're just passing in the type. Now, a quick overview of how Unity works is that Unity is a component-based system. Okay? So all these things that you see here are referred to as game objects. Now, in a component design system, each of these game objects are known as containers. So each of these components that you see right here, like for example, here we have a camera. We also have an audio listener. These are actually all different scripts or classes, if you will. Okay? But they're all contained on this one container, right? Here we have a directional light. We have a light component. That's on top of a game manager. And game object. All game objects must have a transform. So if I wanted to create an empty game object, I can just do that right here. And if I wanted to manipulate it, it's just a regular empty game object. There's nothing in there. But it has a transform. And the transform allows me to move it in 3D space. So we can do left and right. We can do up and down. And we can do in and out, like that. We can also rotate it. So you can see here we have our pitch. We have our yaw. And then we have our roll. So we can, in fact, do a barrel roll. Right? We can also scale it. You can't see the scale because there's nothing here for you to see. Okay, but we can scale it. So one thing we can do, if I just delete this, is I can just create a regular cube right there. And now we have a cube. So now you can actually see that something's actually moving, right? I can hit R, it's an E, and I can rotate it. This is all in 3D space. You're hitting R on the keyboard, I can now scale it. So you can see I can scale things, okay? And all I've done is I'm just manipulating this one component. So the idea here in a component-oriented system is that your components, for the most part, should be independent of each other. Okay? Now, that's what leads us to this particular line, is that this is a call to basically say, hey, Unity, can you look inside of this window, which is known as the hierarchy, and can you find this particular component? So it's going to go through every single object. It's going to iterate through every single object and look for this component. Okay? Now you might say that's kind of expensive, right? And the answer is yes, that is actually very expensive, right? Because if you have hundreds of game objects and each of those game objects have multiple components, it has to iterate through each one until it finds it. So it's not a good idea to do it many times, but here we're just going to do it once at the point of creation. So if I just delete this, here's a plain old game object. I'm just going to add the game manager onto this, and there it is, right? So that it was that simple. I just added it. Just to show you what the component's going to look like. But obviously in our scene, we actually don't have it there, right? We actually don't have the game manager. So we then have to make sure that we check again in the case that, OK, what if the instance actually isn't in the scene yet, right? Then we just check again, just for sanity checking. We say, is the instance still null after we ask Unity to find the component? And if it returns as null, we can go ahead and say, create a new game object. What it's going to do is it's going to go here, basically create a new empty game object. And then it's going to get disabled. So the reason why I disable it is because if I add a component to a game object, right, the way the execution order for the, what they call Unity magic, it actually kind of matters. Because as soon as you add the component, it's going to call awake. And the problem with that is it's possible if you had many different scripts trying to access the game manager at the exact same time, it's possible that you could have more than one game manager, right? Because it becomes a race condition, which is why we have to be careful. So in order to prevent Unity from initializing the script, we have to first disable the actual game object. So it's basically going to create the game object here, and it's just going to disable it, so that when we add a component, none of those components get executed just yet. We want to control that flow. That's why I'm disabling it. Now, my actual reference that I have called instance, I'm actually going to say, get the game object that we just created and add the component. And the reason why I can do this is because add component, if we hover over, actually returns the component you just added. So that's pretty nice. So I can actually just say instance equals, and then game object, add the component, and at the same time, it's going to return it, so that I get that return for free. If it didn't have that, I can say add component to the game object, and then I would have to say something like instance equals game object.get component, right? But I can prevent that extra call by just using this, because that's how Unity has it, so it's pretty nice. Then I activate the game object. So it's like, OK, now let the script get executed to get initialized. And then I call this very simple, don't destroy on load. And that is, again, that's a Unity-specific API call. That's basically saying, hey, Unity, when you switch between scenes, don't destroy this game object. Because in this scene right here is called Untitled. It's a blank scene. I can go here, for example. I have this scene called main, and it's empty. So suppose this main was actually like your main menu, right? After you hit the play button, it's going to probably launch to a different scene, which is going to have your entire game. Well, during that transition, Unity is going to unload this scene, basically destroying all these objects, and load up the next scene, creating those objects. But for a singleton, we just said that the whole point is to just create one reference and then keep it persistent through the entire life cycle of the application. If we just switch scenes, isn't it just going to destroy it? Right? It'll destroy it. And then when you call the singleton again, it'll just create it again. Maybe that's the behavior you want. Maybe. But in our case, I want this game manager to persist. Right? It's not a good idea, but this just as an example. So here I'm just telling, hey, put this in a particular hierarchy and don't kill it. Yes?
So you said you did the set active false and then add component and then set active true to avoid setting off awake?
Yes, just yet, because if I were to just add the component at this point before it returns, Unity will initialize it, calling awake. And if we look at what I have in awake, I'm going to check to see if the current instance, this instance right here, if it's equal to our instance. Because in the case that you have two, let's say you had two game managers in the scene. You're only supposed to have one, right? One of them needs to get destroyed. but which one, right? If they're both, if the scene has just started and you have two game managers, now it becomes a race condition of who's going to die first.
But won't setting it active again also set off awake?
No, because here it's off. The game object is off. So when I add the component, it doesn't get initialized because you can only, Unity will only update objects that are active. So because it's off.
Setting it active, call awake.
Yes.
Yeah.
Yeah. But at this point, we've already assigned the instance right here. So when it gets returned, we already know, hey, this instance is me. We're just trying to check to see the Singleton instance that's currently active globally, is it me? If it's me, we're good. If it's not me, I have to die because somebody else beat me, right? Yeah. So let's just try it here. Okay, and I'm just going to go ahead and let's look at that. Let's look at that case. So I'm just going to go ahead and create a game manager. Call it just game manager. I'm just going to add the game manager, and I'm going to start Unity. Now, you might have seen that the hierarchy actually changed. There's this new scene called Don't Destroy on Load, and you're going to see that there's our game manager right there. So now, if I were to load a new scene, right, this game manager won't die. But if I remove this particular check, deactivation, let's see what happens. Right, so there's my game manager. I'm going to run it, and then, okay, so that's fine, right? But let's try something. Let's, what do I want to do? Yes. Let's not destroy it. Let's just destroy the component. So let's just remove the component. I don't want to delete everything. I just want to remove the component, and hopefully we leave some artifacts behind. So we should have an empty game object called game. No? Okay. So let's just duplicate this and see what happens. So now we have accidentally two of them. Okay, that's what I'm trying to show. So we have a game object, the component is gone, and then we have this second one, and that one actually lived. So that's what I'm trying to get at, is that, and it also depends on when the components get refreshed. Execution order matters. So in this case, the scene is very simple. Not a whole lot is going on. There's no lag spikes. So what I'm trying to show may or may not come off clear enough. But yeah. When you're dealing with Unity, because I've had this issue a lot, it's just best disable the object, add the component, and then enable it. When we do a little more complex scene, you'll see that if you don't do that, you might end up with two singletons, or you might end up with two objects that say they're singletons, but no components are actually added. They end up just dying themselves. They end up killing themselves by accident, right? Because the instance is actually null and doesn't equal themselves, so they just die. That can happen. It's very odd. Okay, cool. Okay. Now, if you want to know a little bit more about the software designs, here in the I have another GitHub repository, and inside here it's not complete, but I actually have the singleton, and I have this completely documented. Okay, so I have all this is commented completely. In fact, I have two ways to actually do this, using just a regular old property called instance. That's a C# thing. And I have another way using a regular method called getInstance, which if you read it in a book or on the wiki, you usually see it as a method. But because we're in C#, we can just use it as a regular property. Okay, so it's fully documented, and I even have the documents for object pool. And this one is also documented, and I think this one's very important as well, especially for games. And we're actually going to go over that too. So let me just create another scene here, just to drive the point home. So just go here. Where's my scene at? Scene. I'm gonna just call this, game or something like that. And I'm gonna load it. I'll save that. I'll just change the camera to a solid color. There we go. So that looks pretty different. And all I want to do is so the start is a Unity magic method. It's part of the execution order. In fact, if you look at the Unity design patterns, I actually have a bunch of links to a lot of the things that you should probably look at. But anyways, when the script gets loaded in, awake and start get called once in a particular order. So it goes awake, on enable, start, and then disabled, depending if you disable it, and then update gets called every frame. So I just want to quickly just as soon as the game manager gets loaded, I just want to switch the scene to the game scene. So I'll go here to the scene manager, load scene. I believe they call the other one game. Okay. So game manager, again, this is for an example. Game manager, as soon as it's done loading and initializing, it's going to switch the scenes. And we'll see that because on the other scene, I changed the background, right? So now we just have to go here to the build settings, and I just need to add the game scene into the playlist here. Now if I hit play, as soon as the game manager gets loaded, it's going to switch the scenes, but you're going to notice that the game manager is still going to exist, and that's kind of the whole point. So you can see we have this whole new scene called game, and game manager still exists, right? Now let's try one other thing. Let's go inside of game, and let's add a game manager in here. I'm going to call this other, and I'll just add the game manager in there. So let's go into main, which has our game manager. And what do you think will happen if you switch scenes to the game scene using this Singleton design pattern? What would happen? What do you think would happen? Because we're forcing that only one of these objects can exist at any point, right? And now I purposely put this game manager inside of main, and I also put one inside of game. So as soon as it gets loaded inside of main, it's going to switch the scenes. And that scene has an object called game manager other, which also has a game manager, which is also a singleton. So what should we expect to happen?
Game manager other shouldn't load up, right?
It shouldn't load up, right? It will load, but we have logic there that it's supposed to destroy itself. So let's see what happens. We're going to hit play. We're in main. Game manager is going to load. We switch scenes, and let's look at game. Game manager other. The object exists, but just the component got killed. Now, why did that happen? Well, because you're supposed to. Here I had changed this. You're supposed to destroy the entire container, right? So if we do it again, but you saw I was able to just destroy the component. You could do that, but what I like to do is if you attach it to a game manager to an object, just destroy the entire thing. And here you can see that game manager other is gone. So using the Singleton pattern, it allows us obviously to control how many of this particular instance exist throughout the entire life cycle of your application. In this case, in our game, we only want one game manager. Does that make sense? Right? And it's pretty cool because if you just code it in Java or something like that, it's kind of hard for you to actually kind of like visualize this. But because in Unity, we can just attach it to the game object. If you want to see, does it still exist? You can just look and just be like, I don't know, yeah, it's right there, right? So that's pretty nice. Cool. So So the other pattern I wanted to go over is something known as an object pool. So an object pool is for video games, or any time you're going to be creating and destroying objects frequently, is probably the most important pattern you'll probably ever learn. Okay, especially if you're interested in doing games, this pattern is going to save you, especially on mobile games. Now, in Unity, there is a method called instantiate. Instantiate basically allows you to take an object and make a copy. Now, it has to make what's known as a deep copy. It has to create the entire game object. It has to create all the components that you have on there, right? And it has to make sure that all the data is the same. Okay? That takes time. It's a process. Okay? So it's very, very slow. And if you're playing a mobile game, and let's say you have a bunch of particle effects, and you're just like spamming the particle effects, if the particle effects aren't that lucrative, they're not that crazy, but you're kind of wondering, why does this game keep lagging? Right? It just keeps lagging for some reason, right? It's possible that the developer is just creating the objects for that short period of time and then just destroying it, and then created another one and then destroying it, so on and so forth. This can create lag spikes because on a mobile device, you're very limited. You have a certain amount of bandwidth in which you can the CPU is not going to be able to keep up, right? It's only has a certain clock rate. It's only so fast, and it may not be able to keep up with all these particles, creating them and destroying them. On a PC, a beastie PC, it's probably like whatever, right? The CPU is just like, it's not even getting warm. It's just idle, right? But on a mobile device, it could be incredibly taxing. So by creating an object pool, right, what we can actually do is we can control how many objects get created. And after they get created, we can actually recycle them. So if the particle is done playing, we can just disable it. And then when you want to use the particle again, we can just re-enable it, reposition it, reset some data, right? And we don't actually have to instantiate it again. So once you instantiate it, it's done. You just do it once, and that's it. Now, so the use case for something like an object pool is the recycling frequently created and destroyed objects. This allows the ability to reuse objects to control spikes in garbage collection-based languages. So Java and C#, they're garbage-based languages. So what that means is when you create an object and you use it, after you're done, and you no longer want to use it, you lose the reference, the garbage collector every so often comes in and starts to free memory that is no longer being used. Now, during this process, it actually has to iterate through all, the entire memory. And during that process, that's very slow. And if you have a mobile game and it's like high action packed, right, things are happening, and the garbage collector is basically going to stop everything, it's going to do its thing, and then it'll allow you to resume. During those times, you'll get real massive spikes in frame times. This causes your frames to actually drop. So you have like 60 frames per second, and all of a sudden it just drops down to like 40. Right? And it's because it's possible that the garbage collector is coming in and doing its thing, and then allows you to now continue going at your high frame rate. So you have these dips. So it's not consistent frame rate. It's very jagged. So poorly optimized games can cause lag spikes, obviously, and undesirable, because if you're making your game, you want it to be nice and fluid so that the user has a good experience. Right? That way they don't go to the App Store or whatever and give you like 1 star. Too much lag, bro, or something, Sometimes something as very simple as an object pool can honestly make the difference. And I've seen it personally in my own projects, that just by applying an object pool has made a huge difference. But with every pattern that you use, there are pros and cons. The biggest con with an object pool is that, well, what would it be? Well, you create the object, right? And now you have to keep it in memory. So if you're on a device that doesn't have that much memory, and you're caching all these objects, well, if you're limited on memory, you're going to start, your bottleneck now becomes memory. So an object pool can actually be working against you if the device you're working on has limited memory. So there's a trade-off. One thing you can do is you can limit how many objects are actually cacheable, right? So here I have an example of an object pool that I created. And so we'll go, actually, I'll just completely just delete it, and we'll just go over this one, because I think this one's pretty cool to know. So we'll start by calling it, object pool. Okay. Now this object pool needs to know what kind of object you're going to use, right? It needs to know ahead of time. So if we don't know, like if we want to use object pool for other things, not just a game object or something else, we want it to be diverse and flexible, then again we're using generics. And as you can see, we have two patterns now, and they're both using generics, which means if you don't have a grasp of how generics work, then you should probably do some research, right? Do some studying on how generics work, because generics are used everywhere, because it allows an API to be flexible enough to work on many types of data types, not just a particular one. So for this example, we'll just keep it something simple, and we'll just use game objects. So in order to use game objects, we need to bring in the Unity namespace. So again, in C#, to bring in a namespace, you say using Unity engine. In Java, you would say something like import, whatever. And for an object pool, you want to keep a list. It's kind of like an array, but it grows in size. It's dynamic. So to do that, in C#, you have to pull it in from the collections namespace, and particularly generic. So again, here we go, generics, more generics, right? It's even in the name of the namespace. And it's common convention to call this, list, this dynamically growing array. In Java, it would be referred to as an array list. That's one implementation of the list interface. As you can see, here's again a T, right? This generic. For our case, we'll just use a regular old game object, and we're going to call it a pool, right? Because it's a pool of our resources that we can use, right? So we're just going to call it a pool, okay? Now, we'll create a constructor, and then we'll give it a capacity, right? Because what if the device you have has limited memory, but you still want to take advantage of the object pooling, but you're going to say, all right, each of these objects is going to take about X amount of bytes, right? If you do your calculations ahead of time, you can say, okay, well, the game, even though it has 250 megabytes of RAM, what if we control it so we only ever have maybe 1 megabyte worth of monsters on the screen or particles or something like that? You can do a simple calculation, do a little bit of math, and say, okay, the amount of particles we'll ever have on the screen will be about 40. So how many of these objects do we need? We'll need to have 40, and that's going to be about 40 bytes or something like that. I don't know. So you can do the calculation, just call it capacity. And this is going to force, when you create the pool, to actually have a capacity. See? You can actually just force the list to only have a particular capacity. So if you try to add one more, it won't let you, right? But what if you want to have no capacity? Just say, yeah, I'm on PC, PC master race. Put as many, zombies or particles as you want, right? Well, in that case, we can't just do it this way. So we need to do a couple checks. We're going to say, if the capacity is less than or equal to 0, let's say the developer puts in negative 1,000, we want to treat that as quote unquote infinity. Okay? And we're going to need to also actually hold what this capacity, the upper limit or capacity here, by the developer. Again, we're assuming that this class is going to be used by somebody, the developer. It'll probably end up being you, obviously, because this is your code, you're writing it, right? But every time I say the developer, sometimes you should assume that you're going to write some code that somebody else might use. Okay? The object pool that I built that's in the Unity design patterns, I built it with no dependency, so if I actually drag that script and just add it to this project, it'll just work. So yeah, so we're going to assume that, hey, this thing is going to be infinite, so we're going to say pool. We're going to say has no limit, and we should be good, right? So if the person passes in less than or equal to 0, we're just going to go with, okay, they mean infinity. They don't really care. Okay, so we just do that. If that's not the case, however, then we can say, okay, create the list with a particular capacity. Right, and now we restricted how many objects can actually get put inside of this list. Okay. And here we need to actually hold what this capacity actually is. So we're just going to say if it's infinity, we're going to say int integers dot max value. This is going to give us quote unquote infinity, right? Or just if it's 32 bits, you know that's about 4 billion items. You're never going to get any close to that probably, right? If not, just based off the capacity. And the reason why we need to know the capacity is because the way the object pool works is you need to know, is an object even available, right? And there's a couple of checks you need to do. One is, if no object is currently available, in that case, we would need to create one. But we need to check to make sure first that we haven't exceeded our capacity. And if we have, then we obviously can't create one. So every object pool, you need to have a way to retrieve a particular item, right, to recycle. You can just call this get item or something like that. Now this get item, okay, is going to return true or false. Okay? It's going to return true if it was successful in getting a reusable item. And it will return false if it wasn't. Okay? In C#, we have this out parameter. You can kind of think of this sort of, but not really, like a pointer in like C or C++, if you know what pointers are. Except that in C#, if you use the out keyword, you have to, no matter what, assign it. So there's a restriction here. You have to assign this particular variable. You need to assign it something. It can be null, right? But it has to be assigned. You have no choice. So is everybody familiar with pointers? Right? Yeah, OK, cool. So then I don't need to go over that. So what's one thing we need to check? Well, we need to loop through. So this can have, at its worst case, big O of n, right? Because we have to linearly search, right? Maybe there's a way for you to use a data structure where you have like some kind of tree that puts all the objects that are available at the top to prevent you from having to, loop through. But whatever. We're just going to do things linearly here. And we're just going to use a basic loop, nothing crazy. And we're just going to iterate through every object in our pool. And our logic is going to be that for an item to be considered available, it needs to be disabled. So remember that in Unity, if you have a game object, like let's say this cube, I can completely disable it by just hitting this little check mark. And it's gone, right? It's not really gone, it's just disabled. It's just turned off. You can turn it on and off. Okay? In code, you would use this is a game object. there's a method called setActive. If you say false, it's like ticking off this check mark. And if you pass in true, it's like turning it on. So you can set active true or false. If it's true, it's going to reveal it. If it's false, it's just going to deactivate it. It doesn't destroy it. It just deactivates it. And that's kind of what we want to do. So for us, an item in our object pool is considered available if it's inactive. So as I go through every item in my pool, right, using the index I, like a regular for loop, I'm just going to check active self, the local active state of this game object. Basically, if it returns true, it means that the check mark is on, and you can actually see the object, right? If it returns false, it means the check mark has been taken off, so it's disabled. Does that make sense? So the item in our pool will be considered available if it's disabled. So we need to check to see if active self is actually false. If we find one, which is good, this variable that I called go, short for game object, I'm just going to set it to the pool. And I'm going to return true, saying, hey, I found a reusable object, an available object. Here you go. And then I'm done there. So that's for case 1. We have to loop through our pool, right? That's the whole point of this. Now, if you end up here, what does that mean? It means that in the items that you currently have in your pool, none of them are available. They're all being used. For example, let's say you have a particle effect, like a little explosion, and it takes like 5 seconds for it to do its thing. And let's say you have another explosion 2.5 seconds after the first explosion. If you check your pool, that current explosion is still in the middle of doing its thing, right? So it's not available. So what happens now? Well, you're going to have to make one, right? So in that case, we just check first. If the capacity is less than how many we currently have in our pool, it means we still have the ability to make one, right? Because if you say the capacity has a certain amount, oh, I'm sorry, not this. If the current amount of items in your pool is less than your capacity, right? The amount of objects that you currently have, if it's less than your capacity, that means you have the ability to create one, right? Because our capacity gives us our upper bound. So if you say, oh, we can only create 5 of these explosions because they're really, really heavy, and you're at 4, is 4 less than 5? Yeah, so we can still create one more. But the next time there's a big explosion, is 5 less than 5? No, right? So what happens? You've met your capacity. So it won't create another one. But in this case, if we can create another one, then let's create another one. So inside of object pool, I should probably pass in what we can call our original. And let's keep track of that. So this is going to be the object that we can actually create a bunch of. Okay. And in Unity, if you want to instantiate something, you use the global function called instantiate. So that's pretty easy to memorize. So the way I like to do this is I usually, say game object. I call it a clone. That's basically what it is, a clone. And I say instantiate. And you can see how it's saying, what's the original? Because it's going to create a clone, right? So I'm going to pass this dot original, which is the original game object. I'm going to create a clone. And there we go. I have a clone. That easy. That's it. It literally duplicated it. OK? Well, now we have our clone. I'm going to add it to our pool, right? And now I'm going to say, hey, the object that you were looking for, here you go. And we return true as in, indeed, we were able to create another clone. Okay? So test case 1, we loop through every item in our pool, see if there is one available. Okay, and if there is, return that one, return true. We found one. Case 2, we weren't able to find one in our current cache. We need to check to see if we have the ability to create one. That's what this part is. And if we are, we create it, we assign it, and we get out. We return true. Case 3, we met our limit. We can no longer create objects. So what do? We set the object to null, and we return false to let them know, hey, we weren't able to create an object. And that's it. This is going to allow you to pool or cache objects they're going to be creating again and again and again and again, and prevent you from having spikes. Only when it has to create a new object will it do what? Will it actually have to create. After that, if it's able to reuse it, that's free. It just turns it on. And that's it. You can, put it wherever you want, and that's pretty cheap. So how do we see this in practice? So let me quickly check to see if I actually have the Did I put it in here? No, I did not. So let me quickly go into documents.
Is that a reason yes we did?
No, because technical difficulties. Push it to Thursday. Paste. Oh, it's going to do the whole thing. Oh, yes, that's what I want. Cool. So I had created this little scene. Say open project. I'm going to add it. So I made a little scene in this one to give you an example. It's just shooting a bunch of little bullet thingies. But it's nice because you can actually see, I'm going to show you in the Unity profiler of how this saves you from actually having lag spikes, right? Because that's very annoying when you're playing a game, and you have all these lag spikes going on because of particle effects or something like that. One thing you can hope to relieve a little bit is doing something like this, an object pool. So just wait for Unity to open up. And I forget that I have to record on a PC, and I do everything on my Mac, so bear with me. So does anybody have any questions of the object pool? It's pretty straightforward, right? It's not that complicated. And all these design patterns, they're not that complicated, and they're pretty straightforward. But what they offer is what a lot of maybe beginning software engineers that they overlook some of these things, and they have no idea that these things can actually help them make their games or software a lot faster. So one example is that I recently had was, and it wasn't a game object. I created a hit scan detection for really fast traveling, quote unquote bullets, really fast objects. And I wanted to make sure that these objects would not pass through, right? So that you can actually see them. Anyways, I was creating objects, too many objects, and I kept, having lag spikes because the garbage collector kept spiking up. And I just implemented an object pool. I had to change a little bit of things, but then everything was steady. I got a solid 60 FPS. I never had any lag spikes. So it was pretty nice. So these things do help. So here I have a little example scene with a gun. This is my little gun. Pretty powerful, right? And what I do here is I think if it's the mouse button or space bar. So I create a little object, right? It's my little quote-unquote bullet. Now notice here how it turned dark. That's because the object is disabled. In fact, here's me turning it on. And there it goes. And then it disables itself. So this has a bullet script, and it has a time to live. So after 2 seconds, it'll die. So if I turn it on, we can count 1 Mississippi, 2 Mississippi, and it's gone, right? But the problem is, as soon as I enable it, what happens? It keeps going where it was last at, right? If I hit the space bar, it's going to reuse that same object. The difference is that if it's able to create, it's going to request the object pool, hey, can I have another bullet? And if it says, yeah, here, sure, all the gun's going to do is just reposition the bullet from wherever it's at, and it places it at the muzzle. In this case, if we look at how I designed this, here's my little gun. There's the muzzle. It's just going to position it there. So if I go crazy, it's creating all these objects. But notice how we have this. So this looks like I'm creating a lot of bullets, right? But after a while, because of how fast I'm actually requesting these objects, it's just recycling. So it almost looks like I have infinite bullets. But I really don't. I actually have this fixed amount of bullets that are actually in memory. You see that? But it almost looks like I have an infinite amount, right? So when you have a game, you're like, wow, like Splatoon, for example. You have all these things going around. You're like, wow, look, unlimited bullets, right? Nah, there's probably like a handful, especially if the rate of fire is really low. It's not that many. I've had games where like it looks like there's a lot, but I'm only ever using like 4 or 5. But it looks like you have a bunch. Like, see here, for somebody that doesn't know what's actually going on, they can't tell. This looks like there's infinite bullets, but there's not. There's a limited amount. In fact, here if we go to the window, and if we go to, where's the analytics? Analysis profiler. Let's look at our profiler here. So I just want to know, okay, it's the only thing I care about. I just care about garbage collection, and I only care about script lag. So I click here, and I go under jobs. No, not jobs. Where am I going? Oh yeah, click. I should be able to click here on main thread. It changed everything on me. Just click on deep profile. Hopefully that'll do it. Okay, so let's look at the spikes. So here we have these spikes here, but they're only going up because, things are just barely loading up. And then let's create one. Oh, did you see that spike? This was our memory. We have a spike in rendering, that's one. And then we should have a spike here in our memory. So we have spikes going on everywhere. Right? And this makes sense because I just created an object. Now, we will have less and less spikes. As things get reused, you're going to notice that the amount of spikes is actually going to reduce. Because after a while, it stabilizes. You no longer have those spikes. So as you can see, like everything is relatively stable, all things considered. Here right now, it's going to be kind of jagged because I'm screen recording. But if I wasn't screen recording, it'd be basically flat. But because there's a lot of other things going on, the operating system might be halting Unity because I have to do all these buffering for the video recording. So let's go ahead and hit clear again. Let's try it again so we can see these spikes going on every time we want one. So I'm going to let it run for a little bit, like warm up. And then look at the FPS. So there's this little line saying, hey, if you're below this, you're about 1,000 FPS. So everything's pretty stable right here, right? Now I'm going to start hitting the space bar to create objects. So there should be a spike right there. There's a spike. There's another. There should be some more spikes, and here there's spikes coming in, and now it's just recycling, and everything's pretty stable. And if I go a little crazy, there might be a little bit more spikes. You see some spikes, and now it's stabilizing again. And it's kind of hard because, again, I'm using a Mac, a laptop, and I'm using OBS, and so it's kind of really hard to show this. But if I wasn't screen recording, you wouldn't have all these jaggedness. It becomes pretty stable. Now in production, obviously that's pretty good, right? Having stability. That's what you want. Does that make sense? So an object pool, again, is very powerful, and it gives the illusion that you have many objects, but you really don't. You have a fixed amount. So there's the illusion behind the curtain, right? Creating games is basically just, creating illusions of reality. If you have a gun, you have like that many bullets, but in the way you do it in a game for a simulation, you don't actually have that many bullets. Cool. So I wanted to create whack-a-mole, right? So I linked it in the Discord. I had a little video. So you guys probably know what whack-a-mole is. You have a bunch of like little, empty spaces, and then you'll have a little mole that pops out, and then you just want to like, hit it, and it should go away, and then you get points. Pretty sure that's how the game works, right? But do you get more points the faster you hit them? So it's based off is it based off speed, or you just have to hit it?
You just have to hit it, but they pop up faster. The delay, how long they're up is smaller.
Oh.
So it speeds up.
Yeah, it speeds up. And as time progresses, the point becomes higher.
Oh, so as time progresses, the mole only pops up for a little bit, like less and less and less time?
Yeah, so it gets from like 10 seconds to like 4, or not 10 seconds, like 5 seconds, then it goes down like 3 seconds.
Oh, okay.
And then points around like 10, 50, 100.
Makes sense.
So what's the end game? Is it just
Well, you have a fixed amount of time, like 30 seconds. You want to see how many points you can get within those 30 seconds, for example.
Every time you hit one of the moles, the next one, you won't get first slightly.
Yeah.
The faster you get, the faster it goes.
Right? Cool, so let's play whack-a-mole. So how are we going to do this? Good question. Well, there's a couple of ways we can do this. Let's do this one way. So let's just design a little game. So here's our camera. Let's bring the camera up, and let's just face it down. So to do that, I'm just going to just rotate this guy down 90 degrees, just like that. 0 on the Z, and let's just say 10 on the Y. So I have my camera here, and I'm just looking down. This is the camera just looking down. And now let's create a surface, right? Because whack-a-mole, they're usually on the ground, right? So let's go ahead and just create, let's try a plane. 0 everything out on the transform, and there's our little surface plane. It's really bright. That white, it's really bright. So let's go here under this folder structure I created, and we'll just call it, we'll call this materials. We'll go to create material. Where's the material at? There it is. We're just going to call this ground, like that. And we're just going to assign this to our plane, just like that, and call it ground. You can call it whatever you want. And if you're curious, you can change the materials directly here. Unity is nice because it has a lot of this drag and drop type of style. So if I just drag this in on top of it, it'll just do it. If I remove this, for example, you get pink. So if you ever loaded up a game and you saw a bunch of pink, it means for some reason the shader, the material was not loaded properly, and then you get pink. So if you ever had like a really poorly designed game, or something's going on and you see a bunch of pink, well, that's why. The material / shader was not loaded properly. So if I grab my little material called ground, I just assign it. There you go, right? Now I can just take this ground and change the albedo, or the color, something a little bit less hurtful on the eyes. Let's try and go for a brown. You know, this is programmer design, so don't judge. There you go. That's a nice brown. There you go, right there. So that's my plane. So that was pretty easy, right? Try to do that in OpenGL. Take you a long time. Just a bunch of, and you know what's cool is Unity has all these little widgets, so that's pretty nice, right? So there's my ground. Now how am I going to, now in Whack-A-Mole, when you see the game, there's like a series of little holes, right? A series of little holes, right? So we don't have a bunch of art assets, so I'm going to just create an empty game object here. Now, game objects in Unity, you can treat them like folders. So I'm just going to create, I'm going to call this my, what should I call this? I don't know. I'll just call it my game board. This is my game board, right? So I'm going to put my ground in there. See how I can parent them? So I have this nice little tree structure, right? So I'm going to create a little sphere here. Again, recenter it. Okay. We can think of this as like the little holes. Again, very bad art, whatever. And I'm going to, let's see here. Move this to the left. Let's get an aerial view here. And I'll put one here. Put one right there. And I have to remove these colliders because hopefully, if I'm quick enough, I want to have this so you can tap, right? The moles are going to pop up, and I'm going to tap. So I don't want the colliders of the sphere to get in the way. So there's one. I'm going to put this under my game board. Create an empty child, and call these holes. And right there. Nope. Right there. I'm going to create another material for the hole so I can color it black. So material, call this hole, and just color it black. Assign this to the sphere, and it looks like I have a hole. Just imagine it's a hole. It's not a hole, but just imagine, okay? So I'm just going to duplicate this and just move it. So there's another hole. Duplicate that. There's another hole. Duplicate that. Make another hole. Duplicate that. And there's one right there. I don't know. You guys be creative with this, and yeah, I don't know what I just made, but there are my little holes. There you go. Nice, right? Ship it? No.
Like it's like they don't have shadows, so they don't. They're like a little bit more like holes.
Okay, so we say receive shadows off. Or where's it? Cast shadows off. There we go. Good idea. And we'll move them down just ever so slightly. There you go. So not that intrusive. Again, you see the bottom, they're all right there, and yeah. Beautiful. That's my whack-a-mole. So that's going to be my game board, right? My little place for me to play around with. Now, how am I going to create my moles? Well, I'm just going to use a capsule. So let's create one. Here's a capsule. There's my mole. And the mole, what's basically going to happen is it's going to center itself around this little hole, and it's just going to pop. It's going to pop up like that. That's it. That's all I want to accomplish. It's going to pop up. So it's just going to do this little thing. And boop. And then you're just going to like tap on it or click on it, and it's going to go away. So this camera view kind of sucks. So let's angle this like this. So let's say 45 degrees, right? 45 degrees is good. And we'll just bring it down. Oh, that's too far. Let's move it back. So say -6. Call that a 5. Nice. So now what's going to happen is we're going to have that, and the moles are going to go boop. Randomly, right? That's all we want to do. Okay. Now, how do we accomplish this? Let's first call it our what it's called. Give it a name called mole. Let's create a material for it. Create material. Call this mole. Assign it to my little mole here, just like that. And what color should the mole be? We have all kinds of colors to play with. All right, we'll just go with that. That's pretty good. Orange moles. And that's it. That's all that's going to happen. It's going to go bloop, right? Cool. So I want this to pop up, yeah? Like that. But I need to control how this is going to happen. I want to animate this. I want to show you guys how the animation works. So to accomplish this, I'm going to create an empty game object right here. And I'm going to actually call this, I'm going to call this the actual mole. So I have a mole. So I have a lot of moles here. Put that in there. I'm going to change this to graphic. That we know, like, hey, this is the graphic. Okay. I'm going to zero this out. So when I bring in my mole, so if I move my mole, for example, let's say it was over here. Oop. -1. Oh, these all have 10s. I see. I see. Whoa. Okay. Because the ground was at, there you go. Nice. I would just want all the y's to be at 0. That'll make this easier to work with. Cool. So then, so the mole will get positioned around here. The logic is we're going to position it here via code, so it's perfect. And then I'm going to animate my mole to just move up like that. Looks like halfway is pretty good. Maybe even a quarter. We'll animate it to a quarter, and then if you tap on it, it's going to go away. So how do we do that? How do we animate this? Okay. Click on the mole. Go to Window, Animation, Animation. Dock the animation. One of your little windows here. Just hit Create. create a folder here called animations. I'm gonna call it show. Okay. And if I hit this little record button, anything I do to this transform or any of the components, it records it. Kind of like, you know, you record like a VHS, but you guys probably don't even know what that is. Never mind. I'm just that old. All right. So what I want to do is I want to record the movement of this little mole guy. So I want to move it down, right? You see how these things turn red? It means they're being recorded. It's being tracked. So I want this to start off at 0. Oh, actually, for show, we're assuming that it's hidden. So we should probably move this down to -1. And we'll say it'll take about, you know, half a second. It'll get to, let's say, 0. And if I seek through the timeline, you can see it animating. That's beautiful, huh? If I hit play, that's my mole animating in a loop. Yay. All right. That's probably a bit too slow, so let's go for about 25. And then that's probably better, right? Cool. And that's it. There you go. Now I need to have an animation for it to hide. So I'm going to click on my mole because it has my animator component. Notice that when I created the animation, it created this animator component. Here on this little window where it says show, I can create a new clip. And I'm going to call it hide. Because the opposite of show is hide. So at this point, we're assuming that the mole is being shown. That's why we're going to hide it. So I forgot what I did here. I put it at 0. Okay. Wait, did I put it 0? Yes. 0 is showing. Cool. So then on hide, we're going to record. And we're going to make sure that we start recording. We start off at 0. And at 25, we hide it. So it's going to start showing, and then we're going to hide it. See that? Showing and then hiding, showing and then hiding. Not bad. Okay. Now, because we're using Unity's animation state machine, we have to use the Animator Window. And if we go here, if we click on our animator, we get our two states here. These are our animation clips that we just created. One's called show, the other one's called hide. Now I want to control the flow of this. So what I like to do is I like to just create an empty state. I set this as the default state. And from this any state node, I just transition to either show or hide. Now, I'm not going to go through this in detail. I will later. I'm just trying to speed this along. If you hit this little plus sign right here. Oh, not there. Control Z. Go to parameters, hit the plus sign. We can go through what's called a trigger. So in code, I can say show, hide, and it'll activate that animation. It's kind of what I want. So I hit show. Make another one called hide. And you see these arrows, this flow? If I click on this, this says, hey, there's a condition here. What condition do you want to use? To transition into this state, hit the plus sign, and it's going to be when the trigger show happens, go ahead and transition. For the hide, we're also going to have a condition. We're going to make it hide, right? Now, when it starts, the mole should be hidden, right? So we're just going to go right here to this graphic and just make it at -1. So it's hidden. Okay. Now, if we hit play, what would happen? Ah, yes, it transitions to the game view. I forgot about that. So let's just disable the game manager for now. We don't need it. And hit play. Cool. Now you see this animator. The state right now is this in this new state. Right, I said that's the default state, right? So the way a state machine works is whatever the current state is, it's just going to update it. That's what that progress bar is. It's just updating the state. Now in code, you can activate these triggers. Since I'm right here, I can just click on the little thing and it'll activate. So if I hit show, there it goes. Oh, but what's going on? It just keeps on repeating itself. That's not what we want, right? That's because the clips by default loop. So we don't want them to loop, right? We just want it to happen once and that's it. So let's click on the show. On the motion, that's the actual clip. Click on that. I can click on it here and then just disable loop time. We'll do that on as well on the hide. So now when I hit play, again, we will do this in code, but let's see what happens here. If I hit show, that's it. And if I click on hide, very good, right? Now what happens if I hit show again? It's like I'm already showing, and it's like trying to blend between two states, but it's like I'm already showing, so it's kind of like, you get that. Yeah, okay, right. So that's pretty good. So what do we do now? Well, we need to create our control here. So I'm going to activate this game manager again. I'm going here. Now I won't make this a singleton, just for now. We need to inherit from mono behavior. So if you want your class to be viewable in this hierarchy, okay, you have to inherit from mono behavior, or else you can't have your script on this container. Okay. Now I need to have access to all the holes in our plane right here, right? So I'm going to create a well, I won't go over that yet. Let's make it public for now. So transform again is this component. It tells you the position, the rotation, and the scale of a particular object, right? So I want to have an array so that in the inspector, this is called an inspector, I can actually assign these objects by just dragging them. That's the nice thing about Unity is you can do that. So I'm just going to call this holes equals new transform, and it's an array. I'm just going to call them holes. And you'll see here that once it's done compiling, we'll have an array of holes. So what I can do now, go to my game board, and I should probably label these hole 1, hole 2. You're right. Damn. I should just drop out now. Alright, hole 4, hole 5. There we go. Now just drag each one in here, just like that. See how it has a little plus sign? I can just drag it in there. If I want to do multiple, I can hit this little lock icon. I just have these three. I can use the shift operator by clicking on them, and then just drag all of them, and then unlock it. There we go. Now I have all my holes. Now we need to know our mole. Call it mole. We'll call it just well, we'll make it a game object. Call this mole. Go back to Unity. And just drag our mole there. And there's our mole. I'm going to move this mole to be somewhere out of sight, all the way like that. Out of sight, out of mind. Okay? Now, very quickly, just so we can see something here. Update is a quote-unquote magic method that Unity will call every frame. So if your game is running at 50 frames per second, this method will be called around 50 frames per second. This method right here is tied to the frame rate. So if your frame rate is variable, like it keeps going up and down, the amount of times that this method gets called is also going to go up and down, up and down, up and down. Okay? So
Update with all C behavior or C# behavior scripts, or is it just mono behavior?
only mono behavior. This is a Unity. Every time I present a new method, something like this, if I call it a Unity magic method, that's exactly what that means. Yeah. So here's a Unity thing called input. Get key down. Just really quickly, I just want to make sure that, or I want to do a check. If the space bar is being pressed, the actual space bar, just for our testing purposes for today, I'm going to move the mole to a random location, and then I'm going to hit, and then I'm going to turn it on. And that's all I'm going to do. Okay? So if that happens, I want to show the mole, and then after a while, I want to disable it. Okay? So in Unity, we have this idea called coroutines. They're not threads, but you can kind of think of it like that, but it's not. It's a thread that's running on the same thread. Basically, it allows you to execute some code a little bit at a time. So you don't execute the entire thing. Like you have a function, it's the whole thing. You're only going to execute bits of it at a time. Haha, bits of it at a time. Okay. So I'm going to just call this, I don't know, show mole, just like that. And here, I know that the mole has an animator component on it, right? So I'm going to say animator, call it anim, is equal to mole.getComponent animator. I'm going to say anim dot, remember the trigger? We have the triggers, remember? I told you that in code we can do this. So I called it show. So I'm going to say set the trigger show. Not bad. Now I can do what's known as a yield return, which is kind of like a return, but not really. And I can say wait for seconds. After 0.25 seconds, I want to hide the mole. Okay, that's about it. So again, this is very bad. We're going to make whack-a-mole. We're going to do it correct, but I just want to have something so you guys can actually see. So I'm going to use the random class that Unity offers. And I'm just going to randomly pick a hole. I'm going to reposition the mole there, and I'm just going to show it. And it's going to hide itself. Right? Ideally for us, we would tap on it, but we're not there yet. So I'm going to say transform hole is equal to the holes that we have assigned in the inspector, random.range. I'm going to go from 0 to the amount of holes I have. And remember, it's just going to give me with the range between 0 and whatever number I pass, except for that number. So it's exclusive. Now that I have the hole, I'm just going to reposition my mole to wherever this hole's at. So I just moved it, just like that. Now I want to do this whole show mole thing. Because this is a coroutine, it's a special type of method that only executes code a little bit at a time. I have to invoke it in a special way. So I would say start coroutine, show mole, like that. Okay. A lot of this is probably new, obviously, but it all makes sense once we go over it a little bit more. But now, if I hit the space bar, my mole should move and then show, and then after a quarter of a second, it'll hide. Hey, there you go. Random. That's kind of our game, right? That's whack-a-mole. So we're almost there, right? Right? We're almost there. See that? Almost there. And obviously, you can increase the time here. This is just for testing purposes, so let's just do like 1 second. Something like that. So you can see the mole, you know. But yeah, that's at least the basics of this part. And after a second, it goes away. And ideally, you would click on it or tap on it, and that would be it, right? Oh, spacebar, right? Anybody have any questions? So, so for Thursday, for those that end up showing up on Thursday, we will continue this, and I hope to get to the point where we can tap. So the game manager will automatically place the mole somewhere until you tap it, right? And then once you tap it, it's going to hide, and then there'll be a little delay, and it'll randomly put the mole somewhere else, and then we'll go from there, right? And eventually we'll have the scoring and all this stuff like that, right? So hopefully that makes sense. I'm going to throw this up. This should be on GitHub. Yes, this is on GitHub. So I'll make a push right now so you can see the code, and you get access to the scene so you can see how it got set up. A lot of this is going to be, this is poorly done, but this is just to demonstrate kind of like what we're trying to do, okay? So hopefully you guys have played whack-a-mole and are maybe have some fun, because once I build it the way I want to build it, we're going to build it onto the device. So you can put it on your Android phone, you can play. Touching, you know, have the whack-a-mole game, you're touching it, you know, on the screen, right? So we'll have that working as well, okay? So if you have an Android device, bring your Android device. The prerequisites obviously have Unity installed, but you also need Android Studio. So this is Android Studio. Android, oops, Studio. No, I don't want you to search for it. I guess. All right, I guess that's the one. I don't know why it has such a long name. Okay. Maybe you're right. Sure. Why not? Uninstall? What? No.
Uninstall old version.
Do you want to quit? Yes. All right. So Android Studio, I put it over here. There it is right there. It should be under, and there it is. Oh, they just have it under Studio, so they just call it Studio. What? Oh, I don't have Java installed on this thing. Okay. No, this is a fresh Windows install, so yeah. So I have to call Studio 64. That's pretty dumb. No, I don't have Java installed. All right, well, will sure still work. Yeah, because these now comes with OpenJDK. Sure, I should be okay. Anyway, we'll figure it out. I'll figure it out if it crashes or something like that. Anyways, this is Android Studio. So you're going to, the only reason why you need this is because if you go to the configure, go to the SDK manager, depending on the type of phone you have, okay, I thought I would have enough time based off technical difficulties. I have two phones here. Well, I have three, including my iPhone. So I have an Android device here. This is the Essential phone, PH1 or whatever. Then I have a Google Nexus, the 5X, old. But for example, this one can only go up to Android 8.1. So here are all the Android versions that you can go. You can all go all the way to Android 2, right? For testing, NuGet is pretty good, because if you have an older device and it's not updated, I think NuGet is, most people probably have NuGet, I guess, maybe. Even Marshmallow 6. The thing is, Google now requires that all the new apps that you upload to the Google Play Store have to be running Android 9 and above. So these apps need to be built for Android 9 and above. For testing, though, just to test, if you don't have a brand new Android phone or a phone that can support Android 9, you can go ahead and use it. Just make sure you pick the correct Android version that you have so you can build to it. Okay? And we'll go over that on Thursday. And on Thursday, we will have this running on an Android device. So if you have an Android device, you're in luck. If you have an iOS, you're also in luck. We can also do it, but you need to have a Mac. If you don't have a Mac, well, why do you have a Windows computer? Right? If you have iOS, you don't have a Mac. I don't understand. So yeah. But I have extra Android devices, so if you don't have one, you can use one of mine. Okay? All right. I'll see you guys Thursday.